All right, so I'm gonna give a small breakdown real quick. All right, so we got 6 neodymium magnets on the outer stator. They're south facing in. I'm just testing out like the bearings and everything. The inner rotor has got 8 coils. At every 90 degrees, you got a pickup coil and a drive coil. All right. I got 2 12-volt batteries in there. Only one of them's being used currently. But what it does is that one drive coil is pounding. It's pounding the pickup system, which is the 4 pickup coils in series that dump into the cap bank. And then I added a super cap for any energy that could be stored, you know, above and beyond. And right now, I think all the energy is dumping into that cap and then being siphoned out of the cap by the other circuit, circuit number 2, which is at 180. Here, let me stop this. So here and here, you've got 2 drives. Actually, it's this one and this one. Okay, so let me turn this on. This is the 6 neodymium south facing inward. Start off slow. So with 6 magnets, it gets picked up pretty fast. It is a little off balance and my clips have come. So when I'm done with the live stream, I'm going to dismantle this and I'm going to figure out where that imbalance is, and I'm going to clean this up. Well, I'm going to put new clips on there and make sure all the connections are good and stay good. So now what I'm going to do is I'm going to take every other one and I'm going to flip it. So now we got a north-south at every 180. So south, north, south, north, south, north. Let's try it. Let's see what happens. So now it's more of a bipolar on the permanent side, and we're going to see what happens. See, that sounds really a lot different, doesn't it? That's amazing power for this little coil. I'm telling you, it's awesome. And it's like instantaneous power. Nothing you got to wait for. I've got several suggestions on what I should do with this. One is to put the piezo transducers on the end of each one of these drives. Just kind of attach it to the end of the coil. I'm thinking about doing that. That might be really a good idea. That would be great, actually. So when I dismantle this thing, I'm going to put 4 piezos on here. Hello. Good afternoon, everybody. So, yeah, let me show you which ones I'm talking about. So these right here, I'm going to put, you know, right on the coil like this. And then hook it right into the coil, you know, short the coil. And that should give us a little bit of extra, whatever we set it up to do, either voltage or amperage. And it's going to boost the frequency. That's what it's going to do. It's going to, the vibration is going to hit it, and then that vibration is going to basically echo in the ultrasonic and then bounce back, increasing the frequency. And you know, when you bounce stuff around and it reverberates inside a closed, confined environment, you get, it's like I don't know, like a camera lens. There was this one video about like this, the light goes into the box and then it bounces around a trillion different ways and then it comes out the hole. And that's how we, I don't know, figure out what color it is or whatever. I forget what the video was about, but it's kind of basically the same idea. The ultrasonic, it's like up to doubles what it's hit with, basically. So let me think here. We want the south. So we had the north, south, right? Okay. So we want to take these out now and go straight south. So all the south facing outwards. I like how these magnets fit in this one better than the other one I made. Oh, I had that one backwards. Huh. Interesting. All right, so these should all be north. North, north, north. Okay. We're on here. We're on here. And now this is without the north. I think it has a little bit more of a pickup. I think the north actually slows it down a little bit. Maybe I'm wrong about that. I don't know. But I got a few more of these tests that I want to do. That's pretty crisp. I think that one runs really smooth. But now what we want to do is a 180 with the south-south. This will be pretty interesting. You do realize that I am not paying it. That's not that I don't want to know what you're saying. It's just that I'm doing this. I'm not even looking at that. So, you know, ask your questions and stick around. Maybe I'll answer them before I gotta go. Hmm. Uh, so this is south-south. This is both south facing in like this. That's smooth. I like that. So 2 magnets is like doable. I can leave this running for a little bit. I won't though. Because there's one more I want to try. That was sweet. That was going to keep, you know, increasing in speed and do it very gradually. That was good. But now, we'll do, let me make sure that's right. That should be south out. Yeah, okay. And that's spinning the rotor to get it going. You can spin the stator to get it going as well. We'll demonstrate that in a second. Oh, I like that. That's smooth. I want to get a nice outer print of a cone that doesn't wobble like that. But the rotor is good. It's not hitting the sides or anything. But it is a little off balance. I think that the north-south 180 magnet here and here is the way to go. It's the most manageable. I love that chirp, man. That's awesome. Don't want that outer part get going too fast or I won't be able to stop it. See now the rotor will get going really fast if I just stop it and hold it. But it has potential to go even faster if I let it go. Just nobody can hook onto that number because the number varies too rapidly to really do any concrete math with. That'd be awesome if we could figure out what the math is though. Then we could hook an Arduino up on there and have it be controlled via a controller. But in order to do that, you got to see this thing counter rotates, and I'm not going to stop that from happening. That's the thing. I'm not going to stop that. That's what makes this what it is. So I don't know if it's hard for you. It's hard for me, but I'm not going to like change it because it's hard. I think it's cool, man. I think it's awesome. Do I know all the science about it? No. I'm pretty sure Scientifica would smack me in the face because of this. Be like, what is it? What does it do? What's its purpose? I guess right now it's to occupy my time and expand my mind, wrap my mind around things that other people just automatically reject most of the time. They're like, no, we can't do it that way because we can't hook an Arduino up to it. Why? Because the math's too hard to figure out when they're counter rotating at different speeds. So I came up with this idea. Get them to counter rotate at the same speed. How do we do that? Let me try this. We'll do a 1-to-1. Now, I heard somebody saying, you can't really do an experiment 1-to-1. Well, I don't have a choice. See, I got a shaft here, and then I got a shaft down there. You can kind of see it in the corner. Right there. There's my other shaft. So that's 1-to-1. So what I'm going to do is I'm going to turn on one circuit. And we're going to have it be a north-south. Let's try this. All right. So this is the battery. This is the one circuit you can run. The other circuit doesn't work unless this one's running. It doesn't work. It's not designed to work when it's off. Wow, that's getting going pretty fast. I'd say, I don't know, I think the outer stator is moving a little bit slower. But here, let's try this. Now that we did that, let's try this. Get the stator going faster and see about the pickup in the middle. See if we can't sync it that way. Because if it's going to sync, one of them's going to slow down, the other one's going to speed up, and it'll be a mellow pace. Or, on this, that's what I'm hoping. I think that's good. I think that's pretty close. What do you think? I mean, do you think that the inner and the outer were moving it around the same speed when that was up there? Yeah, the battery's in the rotor. The rotor is a box, and there are two batteries in here. Let me show you which ones I got. Here it is. Two of these are in the rotor. And I believe that its placement is what's making it rock right now. I think it's a little off center, or is 12-volt battery packs. Yeah, the 12-volt. It's basically, here, I'll get the circuit. I've made a diagram. That's the circuit. I call it a 1, 2, 3. I mean, it's the bare. You take a Bedini circuit and you take everything off of it. That's why it's not a Bedini circuit. Because there's no extra diodes. There's no. It's not a neon light that's in the circuit. It's a halogen bulb, 120 volts. Same type of thing. But it's got a little bit more resistance. But it's just one connection to the base, 2 connections to the collector, and 3 connections to the emitter, and you're gold. That's all you need. This is a 12-volt battery. Juicing this up, and there's like no sign of, there's no heat, there's no anything anywhere that would be bad. As long as it keeps moving, it's going to be okay. And those breadboards, man, that's where my problem was the last time. I had 2 breadboards just kind of burn out on me. And I was like, oh, man. Because I didn't know where the bad connection was. And then I'm like, they keep... I'm like, it's got to be the breadboard. I was right. I mean, when all your circuitry is moving around like that, you're not going to always be able to make sure it's not screwing up. You want to do that before it gets started. Yeah, that shaft is shaking. It might be the center. It might be the shell. It might be the Utron here. Because it's not dead center on the one down here. But I don't know if that's enough to like make it wobble like that. Anyway, it doesn't matter. I'm going to take it all apart. And then I'm going to put it back together with some piezos on it. And I don't know, we got Teflon and electrical tape holding the coils on there right now. And glue. I mean, all right, is that one on? Let's turn this one on. Now, as that 5.5 10 farad cap starts filling up, this will start going faster and faster. Even with the north-south. That's a smooth sound. Heck yeah. See, now what my idea was is to have let it be free, let it do what it wants to do, but have a remote toggle switch that if it gets out of control, you just turn the power off without having to touch it. I don't know how to do that DIY. Seems like something that I should be able to do here though, with all this copper wire and everything. You feel me? I mean, as far as I know, you can get, the coils to resonate that far away, maybe, for a weak one. And it doesn't have to be a Tesla coil to resonate. That's what I was been explained. You know, it doesn't have to be, you know, something that doesn't fit in with what you're doing. It doesn't have to be that way. So it's like, yeah, I'll have to. I think you want the least amount of turns and maybe longer turns. I'm not exactly sure. Maybe I'll just like dismantle an RC unit. But I think to do the power, you actually have to turn the switch on a vehicle. So that probably won't help out that much. You know, and then you get back to the Arduino. You got to control the speed. You can't just shut off the power because that's a manual. But I think there should be a way to like do a triple relay or something like that that'll just turn it off. See, it's that real rocky part, and then I think all the energy shifts to the shaft. And then if it's not equalib, it's going to start shaking in the middle, and that's what I don't like. Wow, man. I put it together wrong. I mean, it works and everything, but the balance is just kind of scary. Or I'd let it go because this is smooth. It's really smooth. It's just shaking everywhere. So what I think is it got the two batteries in here, and I think they're over here is what the problem is. And then everything else is the other way. And I don't think that's the way it's supposed to be. And you got the same amount of weight on all the coils, on all, you know, that's good. There's only two batteries in there, though. That might be the thing. I might put two more in there. I think I need to put two more in there. But then this MagLab is going to touch. No question about it. Yeah, that'd be awesome if that's really a thing. That's what I'm thinking of, a remote control on and off switch. Not necessarily controlling the speed. I want it to go as fast as it can go. But if it gets out of control, I want to be able to just turn it off. Dangerous. All right, there's another thing I want to try. And I really haven't tried this yet. I want to do both of these north. So that's north. Turn this one around. Now let's see what happens. This is Oh, that's smooth. It's a different sound. That's awesome. So every magnet spread that I've tried has got a different chirp to it. I think that's pretty cool. I think the north is pretty good. Um, I guess we could do a triple north now. 120 north. Now the 120 and the 180 in the middle aren't going to sync up. So this should be pretty interesting. I mean, if you tried it with the south, wow. That was, you know, if I can manage to get one of these to print evenly, dude, that I believe is where the real problem is that every one I've printed of these has got some sort of wobble in it, and I'm really getting ticked off. And I'm thinking it's just because of how big the print is. I got suggested maybe to make it in fourths on my better printer and super glue it together. I'm like, look, man, this thing could get going, 2,000 RPMs, maybe if it's balanced well, maybe even faster than that. I'm not going to deal with it like just breaking apart in mid. I don't know, man. I just don't have, I think it should be in one print and be solid, not a bunch of pieces. Not for a rotor. I mean, there are a lot of circumstances where gluing it together is a good idea. I don't think this is one of them. And it's okay. Make one that works. It doesn't prove me wrong. You know what I'm saying? Because even with the whole print, the single print, these magnets, if it gets going really fast, will just rip right through the plastic. I've had it happen. And then you get the true like equal and opposite reaction going in opposite directions at 180 degrees. And it doesn't matter like how big the one part is, all of the rest of it's going the other way. All the magnets, the shaft is probably going to bend. It's going to be violent, It was the last time. I mean, the magnet went straight into the wall, and then the rotor, the shaft, and everything else went into the other wall. So it was just that little tiny magnet bust through the plastic, and everything else just went wham. Didn't matter how much it was. And I mean, the shaft just bent enough for the rotor to just go flying. And it was a 1/4 inch shaft. So I asked for it with the 1/4 inch shaft. 1/4 inch of steel doesn't take much force to bend that, especially at like 2 feet in length. Boom. That was awesome. All right, I'm going to check the monitor here after I turn this off. There it goes. Did you see that? That was synced up. They were both starting to elevate at the same rate. And that's what I'm saying. Once you get that sync up math, the Arduino, you can do it, because then you can increase the speed and decrease the speed of both of them at the same rate. Well, it's all going to be done on the rotor, but you can do that through the magnetism, I would hope. Because, you know, if you just hold this still, it becomes easy. It becomes easier to do. But we're not going to do that. Everybody can do that. Everybody can do this, I guess, too. But everybody does it the other way, and it's nothing I'm interested in doing. I might learn the Arduino and then see if I can, I don't know, we'll get some tack strip on here, and we'll see if we can't sync it up. Get the RPMs for that syncage and go from there. But I'm kind of pumped up right now. Yeah, I got a KC, K1C. I can do carbon fiber. Yeah, that's what I even priced one. To print that would be like $450 bucks. So I gotta be able to do it. I can't carbon fiber with the printer that I'm talking about, though. It's an old school 15-inch plate. You know, I got it for 200 bucks, and I'm not buying a new printer. So the best I can do is probably ABS and do it on silent mode, and that hopefully that'll come through. Now for the rotor, I can do carbon fiber for the rotor, because that's just an 8-inch, and I can do it on my K1C. This is a DC brushless counter-rotating motor. So this is all DC, brushless, and it counter-rotates. So yeah, and everybody has their coils chilling out here like this one. And that's cool and all, but I decided to put the coils on the rotor. And I'm pretty sure there's some more people out there trying to do this or have done it. And what made it really easy is, and the only reason this is as big as it is because of the bobbins. All the bobbins are the same size. I bought them at Amazon. So, and this is the cool part. The drive coils and the pickup coils both weigh the same, and they're the same size. Except the drive coils are 200 turns and the pickup coils are 2,222 turns. But they're the same weight. They're all 5 ounces. And the fact that they're the same size, when that one drive coil hits the series circuit, or the series collector coils, you're getting the maximum effectiveness from that coil to coil interaction because they're exactly the same size. It's just that the imprint that the pickup coil is getting is just a 200 turns of 20 and 28. And I think that, no, it's probably just the 20. If it's the 28, it's a very low. Well, I mean, when it gets going fast, you're going to get more of a reaction there. Because all this stuff, all these coils get juiced up from the magnets. And especially the pickup coils. I mean, I might set it up a little bit differently. I might stagger the coils so that at 180, the pickup coils are closer to the magnets and the other 180 the drive is. I think what makes it work so well is that it's one drive. And that's the other name I was going to have for it, is one drive. Because it doesn't matter what, core, magnet configuration you have on the outside, it's going to run the same way. It's just going to have one more chirp per revolution. Now, because the other drive is purely, it's dependent on the other, it's dependent on one drive being on for it to work at all. Well, here, I'll just turn that one on and I'll spin it just to satisfy curiosity. So without one drive, it doesn't do much. I'm thinking those piezos though are gonna change it a little bit. So now we'll turn one drive on, and then when it chirps, it's gonna generate more electricity than just with the magnets. There's a lot more being generated when they're this close in proximity. And the fact that they're perfect. They're perfect for each other. The pickup coil and the drive coil are the same size, same weight, same mass. Well, I think the pickup coils are a little bit more dense. Because the 30 gauge fills in all the gaps that the 20 gauge has. So yeah, I'd say, and it's weird because the 30 gauge at 2,222 turns weighs 5 ounces. And then the 20 gauge and 28 gauge bifilar coil at 200 turns weighs 5 ounces. So since the mass is really what's important, you can't get a more exact system than this. I mean, you can change the size and everything, but the idea is sound. I mean, the idea is that they're both the same, Therefore, generation is going to be really good, like optimal for the situation, of course. I mean, you can't. I've done all the math measurement stuff, and the way this is right now, you're not changing anything. You'd have to redo the whole thing, and it's because the bobbins kind of set the tone for how big it was going to be. And I think it's perfect. I mean, the bobbins are pretty much almost the same size as the Neos. So that's good. I mean, they're not exactly lined up. This could be better with the lining up. But I can't make the hole in this Utron any deeper or you're going to come out the sides. You know, so it's like I've looked at every single possibility of changing this to work with this, and this is it. And I like it, man. It's good. I'm gonna make another one of these, and I hopefully it'll, like I said, not be wobbly. All right, so we're gonna do some off. We're gonna do 4 magnets now, 4 out of 6, all north facing in. So, and this is because it's one drive. This will work. And then that other drive will hit on this one, on that 180. Once it gets going. All right, here we go. Wow, that's awesome. That's cool. I like that sound that it made from the, just the difference. All right, now we'll do 5 and 1 empty one. Nice. All right, so we're gonna put the other magnet back in. All right. Now the only reason it's being attracted to the rotor is because of the batteries on the inside. When it's off, it's the batteries that are attracting the magnets. But when it's on, it does what it's supposed to do. See, if I let it get going too fast, it's just gonna like not stop when I put my finger there. Mm. All right, so I'll show you the circuit again. Let me show you. And that's 20 and 28 gauge coil, and the power supply or the battery, it's 12-volt battery in this case, but that's interchangeable. The coil is interchangeable as well. So that's just a basic skeletal structure of what's going on. Nothing's written in stone. Here anyway. None of this is written in stone. I could change the size of the magnets. I could change the size of the bobbins. If I change the size of the bobbins, the whole thing's going to change. And that's okay. Like, if that's something I decide to do, then definitely. Definitely. And I think maybe if it was smaller, it would balance out easier. I mean, it wouldn't shake the pole as bad. So, yeah, I'm thinking of maybe a smaller device for my next one. But this is like 5 of 5 for a success rate with the counter rotators. Just different ways I could do them. I've done them with commutators, done them with brushes, now with brushless. Done them with reed switches. The only one I haven't done is a Hall effect sensor. So you get the idea. All the electromagnets are in the middle, all the power's in the middle, all the circuitry's in the middle. And you know why I like 20 gauge so much? It's because it's in the middle. It's literally in the middle. Like if you go 42 gauge and then down to 2 gauge, you put 20 and 22, they're in the middle. And it's just basically the the properties of being in the middle are good. They're good for running a motor and stuff. As you can see, I don't need very much of 20 gauge. Been using this battery now for the past day and a half, I guess, maybe 2 days. I charged it up and then I put it in there, and then I've been using it like pretty much the whole time. So it's not using an abundance of energy, even though the coil's really small. And I'm going to make smaller coils. would say, based on the distance between the coils, the torque on this motor is very, very low. Like if I was to put another, at 45 degrees, put another 8 coils on there, that would have a lot more torque. Like in the gaps here, put another 2 coils per gap. That would work. That would be, I don't know if I'd be able to stop that. But see this one over here that I got hooked up to the cap, like right here. See, there's battery ends right here that I want to hook, just plug in. Because I know that it will run stronger with the battery than it is with the cap. I just know that for a fact. It's a 5-volt cap, 5.5 volt cap. It's a 12-volt battery. And even if I took the cap out of there, I don't think it would make much of a difference because it's run off of this cap bank and the energy that's being picked up by the pickup coils. I think it's always going to be less energy. Might be, I don't know, when it gets going fast, it might actually be more energy, and that's why I kind of keep it the way it is. Because if it's the pickup coils that's driving that, because this cap bank scrubs the AC, bridge rectifies it 4 times, and then sends it out as DC. So it's usable DC, and I just put the extra cap in there just to see if I could do it. And I think the way that I have this clip hooked up, see the energy comes out, goes into the cap, and it goes through. But when this cap fills up, it's going to want to, go either way, and it's going to be forced to go that way. Because it can back up to this point right here where the lights are, but there's a, rectification. All these caps are DC caps, and you can't just put energy in the wrong way on a DC cap. It's rectified. So what I'm trying to say is it might try to back up, but it's only going to be able to back up to here, and then it's going to be forced out through the rectifiers again. So basically the way I think I have it is that all that energy ends up going into the circuit. In other words, I think it's basically pointless for me to have that super cap there. But I wanted to try it and check the clip out anyway. And there's been no harm, no foul, thusly. So I think it's a good connection. I just don't see the purpose for it. Wow. That's weird, man. Fucking retards are good spellers. Hold on just a second. Fucking stupid asshole. that's it. Okay. Let's see if they're both coming undone. No, just the one here. All right, it looks like one of my cap banks has decided to start to come unglued. So I'm going to switch it up a little bit. We're going to do a little bit with my Bedini style motor real quick. All right, so I got an 8 Neo Cube rotor here. All right, so we got our power supply, and the cool part about this, I think everything's still hooked up right. You can hear the piezos going off at 3.5 volts and 210 milliamps. All right, so let me explain what's going on here. You got the energy from this motor. Everything is left over from what I put into it. The 3.5 volts and 150 milliamps. It's going in. Whatever's left from it using is going into this cat bank. All the AC that it's not using is going into this cat bank. Now DC goes in. As soon as it hits that coil, it starts to oscillate. And it's AC. So you tap the coil to the AC accepting part of this cat bank, and DC comes out the other side. And that's what's running this motor over here. And we have a pretty consistent amount of like 2 volts in the cat bank pretty much at all times. But you got to factor in that this cat bank is also running this wheel, so whatever's left over is above what it's taken to run this motor. Again, we're only putting in 3.5 volts. Let me turn it up a little bit. Six volts. We're up to around 3 volts in the cat bank now. Maybe 4. This is awesome. No heat. There's no heat anywhere. And I'm running at 430 milliamps. That's awesome. Well, this switch, the mechanical switch over here might be getting a little hot. It tends to do that sometimes, but I think it's good right now. Yeah, at least times two. Or times itself, I should say. Squared. Double. Hey, hey, what's up? How's it going, society? Alright, so we were playing around with the counter rotator earlier, and now I'm running, I don't even know what this is, but basically the fundamental is you take the AC, you clip the coil to the cap bank, and then the cap bank runs the other motor like that. This is actually the more powerful way to do it. It's not quite a Bedini way to do it. Oh, look at that. Look at the lights. Oh my God, they're so bright. Those piezos are working nicely though. Now, let me get you guys off of this thing for a second. Now that I have hands free for a moment. See, there's the energy going into the cap bank and going out of it at the same time. So well, I don't know. Probably. I would need 4 cubic squares of quartz. So we're doing 6.7 volts in, about a half an amp. Going into this motor right here. And then this is what we have left over and what's being used. An average, I guess. All right, let's turn this one on. Hmm. So that's on this coil over here. There's not much going on. So this motor is running at a very low amount of energy. And so that's why we have so much left over. So that's awesome. So the switch actually takes less energy. Mm. See, so the coil actually has about almost 2 volts AC charging through it. That coil down there. So like the minimal amount, the piezos don't kick in until about 3.5, 4 volts. All right, hell yeah. So, I got my clips. I've got some 3-to-1 clips, and I've got some 1-to-1 clips. So I'm gonna hook it up. Uh, the counter rotated rotor. Yeah, pieces started coming off of it. I'm like, it's time to put it up real quick. Because I mean, those are all got sharp edges on it. If that goes flying off, it's probably gonna like puncture me somehow. Man, I wonder if I could hook this battery up in place of the power supply right now, even though it's like 6 or 7 volts more than I've been putting in the power supply. You think I can hook up the battery to this circuit the way it is? Mind you, 7 volts more than what I've been putting in. Battle bots. Yeah, I don't see really a need to do that. Actually, I do kind of developing a need to do that. All right, let's see if I can do that real quick. I'm gonna put you back up here. This will be it though. Hold on, I gotta check something. Yep, this is gonna wrap it up. Hopefully the transistor will hold out. might not have the clearance. I'll get something real quick. An extension cord. But, you know, I heard the piezos react differently when they're being harassed by a battery. So hey, it sounds like I might be able to hook two batteries up. Do 24 volts, because that sounded pretty low, pretty weak at 12. There we go. Wow, those lights are bright. So that second wheel has to be moving for it to work. Oh, that's so cool. But there is no load currently, so I need to hook up the other battery so we stop wasting the battery juice. But that's pretty sweet. All right, ladies and gentlemen, peace out. Thank you very much for stopping by. I really appreciate it. We'll look into all that crystal stuff once I get a method of cutting crystals the shape that I need them to be. Awesome. Peace. Everybody, thank you so much. Have a great night. Well, afternoon. Enjoy the rain. Bye now.